Greetings, and welcome back to the DevOps track. Oops! Thank you for joining us here today at PyCon. It is great to see everyone here in the audience. Kicking off in our first session now, we have Evan to talk to us about who tests the testers, making testing pipelines. Evan is a senior software engineer whose passions lie in improving the developer experience by enhancing code health, optimizing workflows, and working towards no human errors.com. When he's not thinking about security, informatics, or giving talks about his many projects, you'll find him nomming on Subway cookies or chasing bunny rabbits. Take it away, Evan.
Thank you very much. Cool. I love this screensaver. I think it's very fitting for the talk. But yes, hello everyone. Hope you're having a great day. So I'm Evan, as you might have heard, and I want to talk about pipelines because while working on the platform team, I've developed on pipelines as part of a GitLab repo to run tests for our code base. But I noticed there were quite a few oopsies that were made that could have been prevented if there were tests. And it got me thinking, if we as the platform team help developers run tests for their code, who helps us, the platform team, write tests for running the tests? So today we'll unpack that topic in 3 easy steps. I'll briefly introduce how to make a pipeline and what it is, show how they can break, and finally deep dive into the methods to stop them from breaking. All right, so for this section, could I please ask everyone to raise their hand? Okay, wonderful. We're going to do a little survey, so keep your hand raised. Also, I'm going to ask to take a photo because I didn't think that would work, and I think this is really funny. Wonderful, you look great. Okay, cool. So keep your hands raised, Okay, wonderful. I'll let you know when you can lower them. Okay, so keep your hand raised if you know what a pipeline is. Okay, so we've got a few hands down. Don't put your hands down just yet, but keep your hands raised if you've worked with a pipeline, whether it be in code or work or whatever. Okay, still quite a few. All right, now keep it up if you've written a pipeline. Okay, so there's still quite a few of you that have your hands raised, and that's great. All right, last one. Keep it raised if you've had a pipeline that you've written fail on you. Okay, none of you lowered your hands. I was not expecting this. Okay, we're in for a great talk. All right. So that we're all on the same level. For those of you who hasn't seen a pipeline before, they can look something like this. And to put it simply, you can think of them as a factory line, where each step performs different operations to get to the final product. But in our case, our operations can look something like setup, build, test, with our final operation deploying this built and tested product. So why are pipelines good? And why should you care about them? Well, they allow us, in one case, to create a streamlined process that automates what would otherwise be very manual and tedious. And in other cases, they act as a quality control, similar to a factory line. If any stage of the factory line fails, like building or quality assurance, that item, or in our case, some code, won't progress to the next stage and thus won't be allowed to merge. For this presentation, I'll mainly be talking about GitLab pipelines. However, if you are a GitHub user or you use any other kinds of pipelining tooling, most of the content should be general enough to be applied and additional resources will be given at the end. Okay, so to make a GitLab pipeline, we first need to create a .gitlab-ci.yaml file that GitLab will use as configuration. And that's kind of a mouthful, so I'm just going to refer to it as a CI config file from here on. And if you're new to YAML, think of it as a way to store dictionaries and lists, similar to JSON, but more human-friendly. We'll make a simple one now that one can use on their Python repo to ensure that tests pass before merging. Here we define that we want the job to run the latest version of Python within a Docker image. And then we'll define a job with the name test job. And below, we'll define script as the command to run for that job, which for us will be a Python file called test.py. This is quite simple, probably one of the simplest pipelines we can create. That being said, it probably shouldn't be used as a reference, as it's utilizing a lot of what GitLab is offering by default. And we can get away with not having to install any packages as none are being used. So if you are looking for a reference pipeline, I'll have some links in the resources at the end. That being said, given how simple this pipeline example is, it probably doesn't best mimic the issues that a real pipeline might. So let's extend it to do so. To do this, we'll add some rules, which decide on what conditions the job runs. We'll then specify that we want the job to run whenever there's changes that have been made, such as changes to any Python files. This is so that we can speed up our pipelines by not unnecessarily running a costly job on unrelated changes to other files within our repo, such as documentation. Another thing that we might want to extend on is having to run different types of testing jobs. You might not want to just have a single test Python job. For example, a database test job, which we could set up in a similar way, except it might depend on some test databases to have been created. So for that, we'll require a new setup job to be run, which needs to be run under the same set of changes. And additionally, we need some way of specifying that the database test job can only run once the database setup job is finished. To do that, we use the needs keyword, which specifies that the database test job needs the database setup job to finish successfully before tests can be started and completed correctly. With the idea being that we want as much running in parallel as possible, such that our previous tests don't have to wait for setting up databases if they don't depend on them. And so now what we've landed on is great. It's efficient as an example, and it works when it's merged in. However, as new PRs are made and time goes on, one PR causes the pipeline to fail. Not because the tests themselves pass or fail, but because the pipeline itself is incorrect. GitLab will tell us that the database test job couldn't run because the database setup job didn't run. Now, if we go back to our pipeline definition, can anyone tell me why it didn't run? .pu, yes. That's right. There was a typo in the changes. And so the database test job ran because there were changes to files ending in .py, but the database setup job didn't run because there weren't changes to files ending in .pu. And the reason I give this example is because this is something that's happened to me, right? It's just common error. And so while it's great that we've all figured out why this happened and how the fix could just be a one-character change, in our line of work, it's more important to understand how this was allowed to happen in the first place, so it doesn't ever occur again and we don't have to spend time going and fixing all these one-character changes. So, can anyone think of some examples for why this could have happened? Feel free to shout.
Someone got careless.
Yes, you could have had some careless developers, they're just typing really quickly and it was just easily missed. Anything else? That's a good one. I haven't thought of that one. So the pipeline was updated to a new version that doesn't support the previous things. Okay, cool. Yes?
The setup job relies on configuration files that just happen to be .pu.
The setup job relies on configuration files that just happen to be .pu.
You want to rerun the setup job again?
Yeah. We don't want to keep having to rerun things. Yeah. Anything else?
Lack of testing or safety net.
Yes, lack of testing of safety nets. Yes.
Someone put some of those files on Git, and then you run the job, but you recover the
Right. Yeah. So someone like.
comments.
Right. So I'll repeat it for the mic. Someone ran their stuff locally and they had it, but they hadn't committed it, and so they wouldn't have noticed that problem in the production. Yeah. Some other ones could have been like the config is too complex, maybe the reviewers weren't sharp enough, or we could have written it in a better way to use don't repeat yourself and so forth. But those are all good points. And to me, I think that all of those are all human errors. And as you might have heard earlier, I don't like human errors that could be avoided by a systematic change, which would allow us to blame a system instead of a people. So I would say that at a higher level, this occurred because while this configuration looks like code, it isn't treated like code because we're used to testing code with tests, but who tests the testing infrastructure with tests? So now you might be thinking, Evan, this is great insight, but solutions speak louder than problems. How do I stop this from happening to me? It's a great question. To answer it, there's a couple of methods that we'll dive into. The first is validating our CI configuration using linting tools. The second is running an end-to-end pipeline before committing changes. We'll then look at how we can run those pipeline jobs locally, and how we can run static analysis testing on the CI configuration. Finally, we'll look at dynamically generating pipelines using tools. Now, I'm not going to claim that any single method is the best, but I will cover the pros and cons to help you decide which one or combination works best for you. So the first method we'll dive into is linting the CI config file. Linting is great because it's a fast method of finding problems that can be solved before going further. And GitLab offers quite a bit here. They have a VS Code extension, which will tell you within your editor whether your YAML is set up correctly. They have a pipeline syntax checker, which will do the same thing as the extension, but through a web UI and an API endpoint. They also have a visualizer, which gives a quick way of helping you see the dependencies between the jobs. They have a validator, which simulates a Git push event on the default branch with the rules and needs evaluated. And finally, they have a tool to expand your YAML into its full configuration, which helps you see what the pipeline looks like with all of the special syntax expanded. However, all of these methods have their downsides too. The VS Code extension, as you might have guessed, is only for VS Code. And even if you instead use the pipeline syntax checker, whether it be for the web UI or the endpoint, they only tell you if there's something wrong with your schema, not with how it runs. The visualizer, while handy, doesn't help you understand the issues that we had around dependencies with the needs and rules, and thus won't uncover those issues up front. The validator, while it says it simulates and evaluates rules and needs, and I could be misunderstanding here, feel free to correct me at the end, wasn't able to pick up on our problem, and also doesn't have an API endpoint to make testing easier. And the full configuration tool, the issue with that is that the expansion is limited and won't expand out defaults, since technically each job has an image, but we've just taken it here as the default. And so while linting tools have their use, they are only a single piece of the puzzle, just like how we can't expect linters to catch logic errors. So if linters are lacking due to not testing end-to-end, why don't we instead try running an end-to-end pipeline before merging changes? Well, the good news is that GitLab lets us run a pipeline from a particular branch, such as the one that is introducing the CI config file changes. And it also lets us specify variables, for example, overriding those that would be predefined by GitLab. This is great because it lets us run a pipeline identically, excuse me, it lets us run a pipeline identically to how one would be run by GitLab, such as a post-merge pipeline. However, there is one limitation, being that this pipeline depends on changes for that particular branch. And therefore, we won't be able to catch our problem as our branch doesn't introduce the changes that are needed to reveal that bug. However, there is another way, and that is by creating a branch off of our CI config file changes with the changes that are needed, such as changing a file that we expect to run in the test directory. This is great as it would reveal our problem. However, as you may have noticed, this is quite an intensive and costly process, as it's slow and manual and may not scale with all of the combinations of changes that may be introduced with lots of different rules. And so for our third method, we have something in between, something that's not as static as linting and not as end-to-end as running entire pipelines. For that, we can use tools like GitLab CI Local and GitLab CI Local. Yes, you heard me right. The difference is in a dash. GitLab-CI-Local is a TypeScript tool made by PyConAU in January of 2020. And GitLab CI-Local is a Python tool made by Adrian DC in January of 2020. Honestly, it's just bizarre how similar these tools are, both in what they do and when they were made and their name. But anyways, at the end of the day, these are both tools that let us run individual jobs of our GitLab pipelines locally using containers. And the core benefits of these tools are that they let us remove the dependency on GitLab. We might not want to spin up an entire pipeline just to run a single job. And this is helpful as it quickens our feedback loop by allowing us to locally replicate job environments that might otherwise be too different if simply run as a script. That's not to say that these tools also don't have downsides. For one, being simulators, they're not always going to match the real thing. And if we're solely testing our pipeline changes, they don't give us any static information in advance and require us to wait for the jobs to finish running. And so in our examples above, both of these tools also won't help us uncover our problems, even though they might have other benefits. And so with the fourth method, let's explore a different kind of testing. In this front, I wasn't able to find any kind of static analysis testing tools for CI config files, and thus to solve this problem, I begrudgingly made my own tool. CI test. CI test acts as the missing piece of this linting end-to-end integration testing puzzle by functioning as a framework for static analysis testing. Think of it as a toolbox to add to your shed of equipment. By analyzing the CI config file and how it's changed, we can gain a better understanding of what the pipeline is meant to look like. As an example, it can produce snapshots of the pipeline by collating relevant information, such as pairing together lists of jobs and changes. And so using our example, when the change was made, we would get this diff. This immediately lets us know that an additional rule set was created that is different from the expected rule set from all other jobs. And so really, we should have seen this instead, where all the jobs are defined under the same set of changes. Of course, like everything else, it has its drawbacks and can't solely be dependent on, since it doesn't run in integration like all the other methods. However, it will allow us to quickly iterate on rules with confidence, which was something that we couldn't do before. And that being said, don't take that as me going on the record to say that this will be the holy grail for all your pipeline tests and so forth. There is plenty of room for improvement, and it's been written in a way to be highly extensible. So if you want to help contribute to this or any other developer tooling, I'm more than happy to help. Reach out, make a pull request on GitHub, or come to the sprints. All right, so the last method that I'll cover is using tools to dynamically generate pipelines using programming languages like Python. GitLab-CI-Python library is the only up-to-date library I could find to do this. Although, if you are interested, there are some TypeScript libraries that I had dismissed due to needing some more attention. Anyways, GitLab-CI-Python library, or GCIP for short, is a library from Thomas Steinbach and Daniel von Essen that allows you to replace your CI config file with Python. Now, you might be wondering, why would you want this? Well, if we quote the library, we can utilize all of the features of Python, such as code reuse, variables, control flows, and the like, programming paradigms, libraries, testing, packaging, and anything else you can imagine. The world is at your hands with Python. So the way that these generated pipelines work is that in our CI config file, where we've been defining our testing jobs, we instead define a generate pipeline job, which runs our Python CI config file to create a generated config CI file that contains all of the previous jobs that we want to run. The original CI config file had also defined a run pipeline job that has a needs on the generate pipeline job, as it uses the generated CI config file to then create a child pipeline that runs all the previous jobs that we want to run. This is great because it means we can replace writing all of our YAML with Python. Okay, so what does that look like? If we want to replicate what we had before, our config file would look like this. We import the library, create a pipeline, specify the default image, then we create a job, we give it a name, add a script, and its rules, doing the same for all other jobs, add in our needs, before finally adding all the jobs as children of the pipeline. And then finally, writing that pipeline out to YAML. And sure enough, we can have this pipeline execute in our repo and have all the expected downstream jobs run successfully. However, has this caused our initial problem to go away? Well, it doesn't give us any protections from the pipeline failing to run, because again, there were no reasons for it to run correctly, since there was no .pu changes. And so unfortunately, it seems like generated pipelines won't directly solve our problem. That being said, they can help. As the authors mentioned earlier, this programmatic approach does let you import your pipeline and perform tests on it, allowing us to do something similar like we've done with CI test. However, there is one other thing to consider. Since our pipeline is now in Python, they do let us easily create a change set using a list that we can apply everywhere and thus help alleviate any rule mismatches, as all the rules will now be the same. This may have those of you knowledgeable in YAML thinking, doesn't YAML also let you create a list that can be referenced? And you'd be correct. We can create a key with an anchor and reference them with aliases to do the same thing and solve our problem. But if we wanted to do something like extend this change set, it wouldn't be as easy, as YAML doesn't allow merging of lists. Well, that's not entirely correct. GitLab does allow you to merge lists. However, this doesn't work for all cases because it only lets you do that sometimes, and it won't result in valid YAML. So, are generated pipelines a good idea? I think the authors have a good view on this, which I'll do my best to summarize. The cons are that it could allow for writing complex pipelines that nobody else understands, when they could be basic things that build and test your code and shouldn't be in code too. But if you're not fond of YAML, your CI files are growing to over thousands of lines long, or they're littered with complex rule sets, maybe writing them in code is cleaner. Importantly, it's a choice that's up to you, your team, and the situation. So to close out, if we look back at our methods and ask, what is the best approach? Well, it really depends on what your CI looks like. If your CI config file has become thousands of lines long, generating it dynamically or writing tests may help relieve that burden. But at the end of the day, all these methods are only tools to assist us in our problems. And if the underlying problem is the thousands of lines of CI configuration, it might help to start there instead. Thus, my view from all this is that simplicity is key. Choosing one tool over another will still be adding another component to something that is likely already complex that you will later have to deal with. Question everything that is there and utilize the least you can to get the job done. As always, I'm open to feedback as I'm continuously striving to be better. You can find my contact, all related repos, tools, references, and sources at citest.nohumanerrors.com. And if you're still wondering who tests the testers, I'll be around after for questions. Thank you to my friends, my family, and you for supporting me, as well as the open source contributors, and finally to you for listening. I'll leave this up now so that you can actually take pictures and take a look. Thank you very much.